CAAS Theory guide, and it's a masterclass. So do get your coffee, do get your drinks.
My name is Jonathan. I'm 20 this year. I'm a drone hobbyist for last 10 months to 11 months.
First of all, we should know what is the UA categories. I'll list them down here, and so you guys can see. So it's airship, aeroplane, rotorcraft, and power lift. Airship is a very light, okay, very basic. Aeroplane is airplane, and rotorcraft is a drone, etc. So what's a UA? A UA is a unmanned aircraft, or commonly known as drones, that is maybe flown or used without any individual on board. You don't need to be inside the plane or inside the UA to operate it. And the UA system, UAS, refers to the UA and its associated elements like the controllers and etc. So next slide, how do you remember this? Aeroplane is fixed wings. They also don't move, meaning that they don't come out. How do you remember this plane? Is a fixed wing. Very common sense. Okay. Rotorcraft is like helicopter. It's a one big rotor on top. Okay. And the rotors spins to lift and move. Okay. If you think about it, it's like heli in one rotor, meaning it's like helicopter. Rotorcraft multi-rotor is a several small rotors. Meaning, example like drones, you can see drones having small propellers, right? So multi equals to many rotors. Okay, power lift can take off upwards, vertically upwards. If you think about it, it's 2-in-1 aircraft, up like a heli, fly like a plane, meaning that it has endurance. Yeah. So airship uses gas and helium to float, meaning it's like a balloon that floats in air, but it uses gas, and it's lighter than air balloon with an engine. Okay. Next, UA applications. Let's go through some ways that the UA you can use for maybe. Here you can say real estate marketing, precision architecture, search and rescue protection. I mean, you have seen a lot of videos going around using drones to find people and protect endangered species, and many more. So you can pause and read through, and it's quite interesting. And you can research on they do use as search and rescue. It's not tested, but I will recommend you to research a little bit and find out for yourself what is power distribution board. Distributes power to the battery, to electronic parts, and you can separate board or build into an aircraft frame, meaning that yeah, you can just build it in. This is tested and your UA systems are tested too. So do take note, I will continue to update you on which is tested and which is not tested. So our power management unit, PMU. So PMU is the external modules to deliver power to the main flight battery, and it can monitor power usage, send data to the flight controller. So PMUs usually power the flight controller like sensors, RC receiver, telemetry unit. Also check the PMU voltage rating. It's based on LiPo cell count that I will also tell you later before connecting it. It's very easy to remember. PMU equals to power plus monitor plus understand limits. So it's got PMU. Okay. LiPo batteries. LiPo stands for lithium polymer. I don't know how to pronounce it, but okay. A common battery type used for drones. Okay. It provides electrical power to all the components. Each LiPo cell has a normal voltage of 3.7 volts, also called 1S. Okay, safe charging rate is 1C. Then you must remember this as it's tested also. So which means charging current equals to 1 times the battery capacity. So for example, you have a 22,000 mega ampere battery. So that is equals to 2.2 ampere for 1C. Okay. So the easiest way to remember is LiPo equals to light, powerful, 1 cell equals to 3.7 volt. I mean, you can pause here and read through. This one is most important. Propulsion system is propeller, DC motor, ESC. ESC is electronic speed controller. Electronic speed controller. Okay. This is a must remember. DC motor is a brushless DC motor, converts electrical to mechanical motion without brushes. Okay. It uses electronic controllers to switch current to the motor windings and to create a magnetic field. I won't read through the whole thing. It's just brushless motors that use DC current. Okay. If you don't know what's DC current, it's just a coils inside. This is how I remember. This coils inside. Okay, this brushless. I don't know why it's called brushless. Propellers. This one is a bit to explain. The tip is here. This is the leading edge. Then the rotor, the clockwise direction. The trailing edge. The hub. The hub's one center, one hole, just to put in the screw. And then the counterclockwise propellers. This one you have to can pause and you can read through. It's just the direction of the propeller, or maybe anti-clockwise or clockwise. Yep. So I think the red one is anti, the blue one is clockwise. Yeah. Servos. I think you can search them on Google. It's called servos. I think maybe you can put servos for drones. Then they'll give you some photos. So servos move an aircraft control surface, and helicopter swash plates. And you can also operate landing gears, cameras, or doors like aeroplane. Interior Management Unit (IMU). This is very important. So there's there's a pitch and there's a roll. Example, let me take something. Example, this chicken wing. Okay, chicken wing has yaw axis. You can turn the chicken wing side to side. Okay, pitch is going towards you. Okay, very easy. Remember, roll is just turn. Okay, I will explain a little bit more on details later. But IMU is to measure the orientation of the chicken wing or the drone. Okay, so there's one here, and one here, and one here, one in the center. Okay, so the flight controller is the brain of the UAV, and it interprets sensor data, the pilot commands, and the common sensors include the GPS, IMU is just now we talked about, barometer, we will talk about it later, and magnometer. It measures various autonomous flight modes. Okay, so it's the brain of the UA. It has sensors like GPS, IMU, and the controls. Okay, barometer, as we talk about, is to measure the decrease with height or the increase with height, meaning that it can sense a pressure when it drops height. Okay, barometer is to measure, it's a pressure sensor, and it's combined with GPS to calculate a better altitude accuracy. Okay, global positioning systems, like your GPS, Google Maps, is to get the certain location. Normally it's placed antenna on top, meaning the drone is here and the antenna will be on top. Is to stabilize the position and to record a home point. Home point is when you hold the button long enough, the drone will come back to you. Okay, enable autonomous flight. Okay, if you don't want autonomous flight, please Google it. I think, yeah, it's very important to understand this. Magnetometer is the GPS to show us our position but not heading, meaning that if you don't have magnetometer, the drone don't has a head. So magnetometer is there's a head for it. Okay, so it's a GPS position only. It's got heading and you can adjust to the true north. Okay, it's sensitive to the interference and calibrate regularly. You have to calibrate lah. Combine GPS plus whatever, etc. Okay, please read through. I don't think this is very important, but good for you to know. Okay, next, please identify the 40 faults, and this is very important. Okay, motors. For motors, we do ensure the motor spin freely. Uneven spinning may indicate that it's damaged, or compare motors with each other for similar performance. Okay, propellers flex slightly before mounting to check integrity. Inspect edges, tips and cracks, and then connectors or wiring check for pinching or exposed conductors, meaning that it's out. Ensuring that creams are secure and not exposed, and batteries, make sure that's not bloated. Ground control system is those components essential to fly safely and effective operations. Okay, and collective called the ground control stations. Okay, so the key points for memorization, we can use ground control based components like telemetry and video links. Telemetry is your device. Okay, essential for safe operation is called ground control system. Interface devices, where we come to, we're going to talk about telemetry and etc. So ground control device is the displays from the UAV to the monitor status, provides to controls for the aircraft. It can be like laptop, or tablet, mobile phone that's running a mission software with necessary drivers for telemetry and video ready-to-fly devices, okay, and all systems, like example DJI or Parrot. Sorry, my switchy. Okay, so it's usually integrated both telemetry and video, while custom UAS setups has separate device. Okay, so it displays a screen. So if you can see this iPad here, it displays something. Okay, and it provides control like command controls, and the device can be a tablet, laptop, etc. The telemetry receiver is either TX or RX. Telemetry systems combines a transmitter and a receiver into two separate wireless data between the UAV and the GCS. GCS is ground control system. It connects via standard interface, is often specific to the mission software like DJI system works. The two-way wireless data transmitter plus receiver, please remember this, and it connects via a standard interface. Okay, maybe system specific. Example, DJI only works with DJI remotes. Ensure you have clear line of sight. Okay, RC transmitter, RCTX is in short form. Okay, RCTX is a electronic device that is wirelessly sends radio signals to the UAV receiver, okay? And it has a basic flight control commands like throttle, elevator, aileron, radar, as well as secondary commands like gimbal, controls, or flight mode. Example, TX equals to transmitter, and it sends radio signals, and it receives at a UAV receiver on an aircraft. Okay, so basic flight commands is like throttle, blah blah blah. Okay, secondary commands is like gimbal and flight modes. Okay, next we have channels. We have about, I think we have 5 channels. Okay, we have 6 channels. So 6 channels. Fourth channel is minimal, like throttle, pitch, roll, or yaw, and then 6 channels common at flight mode and gimbal, and RTF systems represent DJI or Parrot. Our custom builds are planned channel assignment. So basic transmitters at least have 4 channels to control the throttle, pitch, roll, and yaw. Okay, so most rotors or UAVs use 6 channels to add the functions like flight mode, that's for channel 5, and gimbal control for channel 6, and it's ready to fly systems. Okay, so receiver and command and controls. RDS is a radio receiver. Inside the UAV receives a signal, and it sends them to a flight controller for the flight commands or mode changes. Means you move your sticks and then the drone will move. The transmitter and the receiver must operate on the same frequency, meaning sometimes 2.4 hertz, 3.4 hertz, whatever. Okay, so RX receiver inside UAV. Your binding is paired with a TX. So bind RX to TX, and then it's unique pairing, meaning there's a unique system. As a binding process, a button or plug-in method, and then RX responds to the paired TX. Okay, so UA flight controls. I think a lot of these slides are very important, so we'll read through them. Very important. This one I won't go through much. The altitude hold is different. And yeah. So GPS modes, as we talk about GPS, return to home is going to the same place that you set home, so the drone will fly back home. Okay, collision avoidance. Nowadays, a lot of them. Headless modes. It controls the head of the drone. So, example, if there's no head, you just fly like that anyhow. So, importance of flying within the radio line of sight so that you don't get a drone missing. Radio line of sight is like flying blindly. Okay. So it relies on camera view. That's BVOLS. Okay, very important to remember. Transmission range limit. Video may drop. So meaning that you go far away, the video resolution may drop and suddenly lose connection. The consequences is a flying blind, meaning that the drone just disappeared. Okay, don't do that in Singapore, or don't do that in other countries also. Okay, radio interference. Most UAVs operate in 2.4 GHz or 5.8 GHz. Other radio transmissions in the environment can interfere with these signals, meaning that you can have low signals suddenly. Okay, so make sure you see it. We're halfway there. Okay, so bear with me. So multipath interference occurs when reflected radio signals, meaning that, example, you have 2 buildings, you just reflect or anyhow reflect. Okay, such as terrain, such as hills and block, or weakened signals we are building and vegetation, especially wet trees, or it can reflect and absorb or weaken radio waves. Multipaths signal, reflect, interfere, terrain, blocks, whatever, etc. So preventing interference, UAV pilots can minimize the interference by avoiding other UAVs in the area, or selecting channels far away from the interference signals, or turning off nearby wireless device, such as your Wi-Fi, such as your Bluetooth. Okay, flying in open areas away from strong EM or radio sources, like your power lines, towers, or tall buildings. Yes, what I mentioned, tall buildings, right? So it just reflects. Okay. So link loss can happen due to radio interference. That's what we mentioned. Usually the UAV triggers RTH, return to home fail safe. In rare cases, RTH may fail. So keep your drone within line of sight. Okay. So mass flyaways, however, are due to common pilot errors. Most of it is pilot errors lah. You fly near the radio stations or fly near a very tall building. Okay. Link loss, you can remember all this, it's quite important. Okay, so that's all for this video, but tomorrow I'll be uploading another series, so if you're interested in other videos, do check it out, and we'll see you then. Bye bye.